All right, guys, in this video, I'm going to talk about the vertical motion, and I'm going to call this video kinematics number 8, vertical motion. So when you're looking at for it, that's what it's going to be called. All right, so vertical motion is no different than horizontal motion. It's the same concepts we're going to be using. So I'm going to take that number line, that imaginary number line we talked about in horizontal motion. I'm just going to rotate it 90 degrees. So here's my origin. And I'm always going to choose my origin, the point from where I throw the object. Either I release it or throw it up in the air. So first I'm going to start actually with just something that's falling straight down. Okay? And I'm going to choose anything below this point here as a negative position, right? And any object that's moving down is going to be moving in the negative direction. So basically all my velocities will be negative or have to be negative. The advantage, the only thing that's good about this is that the acceleration of gravity, if it's in a vacuum, if there is no air resistance, will be a given number. So we never have to worry about it. So the acceleration of gravity is just going to be negative 9.8, or actually, you know what? Let's just make it negative 10 for simplicity. Negative 10 meters per second, which means that if I drop something, it's going to gain 10 meters per second in velocity every second. That's really all it means. So let's try an example. So let's say I have a building here that is, or maybe just a height of negative 100 meters, or 100 meters. But in terms of displacement, if I start here at 0 and I'm below this point, I look at this displacement as 100 but negative. And I want to figure out how fast I will be going the moment I'm going to hit the ground below, and how long will it take this object to drop. So I'm not throwing it down, I'm just dropping it. Okay? So looking at the equations, I have the delta x, I have the acceleration, which sometimes we call it g. It's negative 10 meters per second squared. Now I'm releasing the object from rest, which means my initial velocity is just 0 meters per second. So if I have three things, I can figure out the other two that are missing. So I'm going to find the velocity the moment I'm going to hit the ground. So that's going to be, I'm going to use this equation here, the simplest one, the linear one. Okay, this is 0. The g is negative 10, and the time we don't have. So I think we should have found the, maybe do another equation. I think we'll try this. Delta x is v0t plus 1/2 gt squared. So let's get the time first. It doesn't matter. I think I could have used the one without the time to find the velocity at the bottom. So this is negative 100 equals, this is 0 because I'm dropping it from rest. It's 1/2 times negative 10 times t squared. So t would be equal to radical 20, it looks like. Okay, which is about 4 and change in seconds. If I want to find the velocity at impact, I can use this time and just pick the linear equation, the VF equals VO plus GT, or I can just, if I don't have the time, I can just go with the last one, plus 2g delta x. Now, sometimes I'll be calling this delta x delta y just because it's vertical, but it really doesn't matter. You can call it delta x if you'd like. This is 0. The VF squared is equal to 2 times negative 10 times negative 100, and VF equals, now you have to do plus or minus, and the answer is going to be in meters per second. Now if you're talking about speed, we'll just pick the positive value. If you're talking about velocity, you have to keep the negative in there because you're traveling in the negative direction. Now let's look at some conceptual parts to this problem here. So if I want to figure out how fast I'm going after 1 second, all I have to do is think of the acceleration. Now the acceleration is 10 meters per second, or negative, it doesn't matter. So if I start from rest, it means after 1 second, I'm going to pick up an extra 10 meters per second in the negative direction. So my velocity will be negative 10 meters per second. Another second later, which means 2 seconds from the beginning, I will be going at 20 meters per second down, which means in terms of velocity, it's negative 20. And we should see that as you're traveling down, the distance traveled every second should increase because of the acceleration. Now let's look at an examples where we're throwing something up in the air. Now the acceleration, which is g or a, it doesn't matter, is negative 10 meters per second. So here's my number line again, is 0. That's going to be the launch point, right? So that's what I'm going to throw something up in the air. Now anything above this origin, all the positions, in other words, are going to be positive. All the positions below that point will be negative. Each time I'm traveling up, that's a positive velocity. It doesn't matter what I do it from. Each time the object is moving up, that's a positive velocity. Even if I choose this as my 0 and I throw it from down here, it doesn't matter. Okay. Each time I'm traveling down, that's a negative velocity. It doesn't matter whether I'm above the origin or below it. So this is going to be a negative velocity. So let's just make sure we understand that. But to keep it simple, just choose the launch point as your origin. It just makes the math simpler.